Hello everyone, my name is Elma and today we are going to start with the chemistry class. So first of all, I would like to request everyone to please turn on your cameras, take your pencil, pen and notebooks along with you for making notes. So today's class will be of chapter acid bases and salts. And for that we need to understand some of the basic things. So let's start. Is that my screen is visible to everyone? Okay. So what is the name of chapter? As the name of the chapter is acid bases, and salt. What is an acid? How you will identify that it is an acid, how you will identify that this is an base, and how you will identify that this is an salt. Anyone can tell? Yes. We can use two things. The first one is indicators, and second one is pH scale. By using these both, we can understand that we are having acids, bases, or any kind of indicators. All right, so let's start. Okay. So let's start with the pH. What is a pH? Yes, this is a pH scale. All right. So pH, first of all, we need to understand that what is the value of pH, what is its full form. So pH. pH means it is the power of hydrogen. Like where hydrogen ions are more and where the hydrogen ions are less. So with this scale, okay, so this scale ranges from 0 to 40. This 7 is neutral, as you can see. It's a neutral case. Any examples for the neutral? Yes, water. Nearly blood can also be neutral. One more thing is that like if we go from 7 to 0, they all will be acidic in nature. And from here to here, they all will be basic in nature. So acidic and basic nature means like they are having H positive ions in less or more amount. Okay. So let's have example first. For example, we are having a solution and we need to check that whether it is acidic or basic in nature. So for acidic, what works is we have both H positive and OH negative ions in a solution. But what if H is more and OH is less? For example, we are having four hydrogen and four OH. Okay, let's see that we are having six OH. So 4H and 6 OH. So 4H will vanish 4 OH, but what about the other two OHs which are left? So this will tell us that it will be basic in nature. Similarly, with acidic content, what about if I say that I have an acid content? What does this mean? If more the amount, more will be the acidic and basicity in the nature. Like I have three OH groups and six H positive groups. So three OH will manage 3H. But what about the left 3H ions? So this will decide that it will be of acidic nature. So whenever we are having more hydrogens left, that means it is acidic. And when we are having more OH left, it means it is basic in nature. And 7 is neutral. As you can see, there is a color differentiation also. How this color differentiate? For example, in the acidic content, you can see that there are a lot of warm contents are there. Like see this side, light, because they are weak acids, and then after that they all are warm contents. So this is the acidic, like see here, this is a weak acid. So it is a little cool tone, and these are the strong, strong bases, and these are the weak bases. So how we can differentiate in both strong and weak things? So weak means they do not dissociate their ions completely, which means they have dissociated their ions only partially. So partially, that is why they are near the neutral things, neutral atoms or neutral solutions. So 8, 9, and 10. These are weak because they do not completely dissociate. What about 12, 13, 14? These are the strong because they have completely dissociated their OH negative ions. Same in the acid cases, like 6, 5, 4. They 3 up to 3. They are weak because they did not have completely dissociated their H positive ions. And in the strong acids, for the strong acids, they have completely dissociated their H positive ions. Alright. So have you ever wondered that we daily eat some kind of junk food like we eat burgers, we eat chapatis, we eat milk, we drink milk, we all even the dairy products are there, and vinegar is there used for cooking. So what are the lemon juices there? So what are the acidic character of this? Acidic, or maybe they are having a basic character. How you will identify? Okay, let's start with a simple one. What does a blood stands on the pH scale? Where does this will stand? Obviously, this our body will contain all the blood and even the water also, since they both are neutral in nature, likely to be 7. So in the same case, let's understand some more examples. Yes, so these are the examples. So battery, it is of, yes, batteries of, yes, acidic nature. Lemon also acidic. Stomach acid, vinegar, tomato, coffee, milk, somehow milk, then water. These are acidic. What about the basic ones? Blood, baking soda, ammonium, bleach, soap, stomach tablets, and some drain cleaners. Why this blood is not 7? Because it has some of the acid content also, and we drink lots of water, and we eat a lot of the food. So accordingly, that by mixing after that, all the things will go in blood, and that is why blood is not proper 7. It is about 8. So have you got this? Any doubts till now? Okay, so let's revise it quickly. So what is a pH? It is a power of hydrogen ion concentration in a solution. Wherever the hydrogen ion concentration is more, that is known as acidic, and where the hydrogen power is less, that is known as basic. Which means in the less part, basic will have more OH, and acid will have more H positive ions. Acid will have more H positive, and base will have more OH negative ions. So it ranges between 0 to 14, and then acidic will be 0 to 6.9, 7 is neutral, 7.1 to 14 will be basic or alkaline in nature. We have done this pH scale. We have done the examples also. Any other example you want? If anyone wants to ask, or if anyone wants to give, yes, orange juice. Yes, it is also acidic in nature. Okay, so let's learn some of the important things for the daily life. For example, soil. Just pH of soil Why do we use soil? Yes, we use for the plant purpose to the proper growth and development of the plant. So ideally, it is having 7.1 nearby pH. So it ranges between 6 to 7.5, which means this is an ideal plant growth pH. So soil is having a pH of 6 to 7.5. Next is stomach acid. We are having the kind of HCl type of thing in our stomach so that it can all the food can be digested. So all the antacids neutralize it. The excess as available. Sometimes we feel acidity or discomfort. How we will feel this kind of comfort? Why do we feel that? Somehow we have eaten. We Sometimes you can see that you have eaten a lot of things which has like samosa is there, just ghee, oil, or some kind of thing is there. So it will let us feel uncomfortable. So it means acidity is there, and and due to acidity, we need to neutralize it because irritation will be there and some of the things will be there. So to neutralize it, neutralize, you have to add some of the base content or acids. For example, eno is there, magnesium, milk of magnesia is there. Somehow you have to use that to just neutralize it and avoid the discomfort you are facing. Okay, next, Sudhike. Do you remember that sometimes our younger sisters and elder sisters, and the mothers, the elders, all the elder persons, they say that you need to brush twice in a day. Why we say this always? Because when we eat sugary compounds, it will make the pH of mouth 5.5. So because of that, it will be acidic in nature, and we need to use a paste, a Colgate type of thing to just neutralize it because it contains of base. Next, life, aquatic life survival of the plants who are in plants or animals who live in this world. So we know that they live in water, and also it will be little alkaline, little acidic will be there, but it should be nearly equal to the neutral content. So how do you recognize that you are having a base or an acid? By pH paper. Okay, let's move towards the next topic. This is all about the pH. The next is indicators. What are indicators? The indicators are of two types. The first is the color indicator. The second will be a smell or odor indicator. Color indicator are known as acid-base indicators, simply indicators, or color indicators. Smell indicators are known as olfactory indicators. So there are, so let's do first color indicators. Color indicators are first is litmus paper, second is phenolphthalein, and third will be methyl, or this is written here. So how you will be able to know? So we need to learn their results, like in where they will give what kind of things, where they will give color, where they will give original color and things. Okay, let's write the original color also. And in the neutral solution also, how they will do color, how they will show the color. First is litmus. Its original color is purple. So in neutral also it will show a purple color. But what about acids? It will turn to red. We can take the strips of litmus paper. It will of blue and red color. Both are there. So if we place an acid on red color, it will remain red. If we place base on this, it will begin blue only. So what about the acids? How to check acid? We will place one drop on the blue litmus paper and it will turn red. So it means it is acidic. For the base, it will turn blue. Next is phenolphthalein. Phenolphthalein is its original color is colorless. In acidic, it is also a colorless, but in base it will be pink. Same with the methyl orange. Methyl orange is orange in color. It is pink in acid and yellow in when it get contacts with the base. So in original cases or in the neutral cases, they will be same. Like for example, litmus is purple originally, and in neutral it will also be purple. Phenolphthalein is colorless originally, so in neutral it will be also purple. Methyl orange is purple originally, and it will be neutral in yellow and will be there and same in the neutral solution. So this is all the three famous indicators. Where the synthetic, the litmus is a natural indicator, and phenolphthalein and methyl is the synthetic indicator. The next one is smell indicator, or we can say olfactory indicator. So there are three types of olfactory indicators: onion, vanilla, and clove oil. So we will study in acid and bases the results in acid and bases. So in acids, if for the acids, if we place some kind of acid, onion solution or an onion thing, so it will remain. Yes, it will remain its smell, and the base it will lose its smell. In the vanilla sense also, it will remain the smell, and in the base it will lose smell. Same with the clove oil. In this it will remain, and in which it will lose the smell. Clear, everyone? This is a DPP, the daily practice questions. So you can take a screenshot of this. Like first you have to define pH and state the range. To decay, you have to give reasons: pure water, one indicator and their behavior. Neutralization reaction. Like neutralization reaction is that where acid and bases will collectively react and then form a neutralization reaction, and it will form a salt. Effect of the pH on the plant, you have to tell, and then the universal indicator which can help determine the pH. So you can take a screenshot of that. Okay. So this was a lecture for today. I hope you will understand. If you have any query, then you can ask, or we can customize the things according to your requirement. Like which class do you require? What time do you require the class? Hours? How many hours do you require? And also a feedback. We can customize our things to get a best feedback or to meet the best level of your understanding. So you can pick any one of the following. Like it was a super class, it was super awesome, it was a great, it was good, or you need some improvement according to your knowledge or according to your subject. So you can take any of the following, which I mentioned here: awesome, great, and so if you think it is a super awesome or great, then you can tell us that what thing had wowed you. We are always available for the feedback. So, okay, everyone, that was it. Revise the chapter, revise these both topics, and we will meet in the next class. We will solve the DPP first. Okay. Any doubts? If you have any doubts, you can share. You can ask. Okay. Thank you, everyone. We'll meet tomorrow.